Hello and welcome to the KIM-1 Resurrection Series Part 5. In this episode we'll be looking at this board, which we're going to be using to test the D0 and D6 lines to see where the problem lies. I created this small board. This is the edge connector that's going to plug into the KIM-1. And over here there's a ROM chip on it, a 2K ROM and a 2K of RAM. And it is an extension to the address decoding. Now the KIM-1 wants the input, which is KA, that's slot A input K, particular terminal. This is the signal that you have to pull down to enable the onboard address decoder. So here I've got here a 74138 and I've fed addresses 13, 14 and 15 into it, which are the top addresses. So when they're all 0, Y0 will go low, and that will enable the onboard decoder, so decode the bottom 8K of memory. Now the idea of this board here is the ROM here will sit right at the very top and the RAM just below it. So this is 2K ROM, but it will actually be sitting in the top 8K and it will repeat 4 times. I can put the reset vector in here and it will pick it up as being right at the very top at FFFC and FFFD, but when it runs the code it'll be running at a lower address. It doesn't matter. I've only got 11 addresses coming in there. You notice there's no address 11 and 12 decoded here. That's why this repeats 4 times. The RAM is exactly the same, and that will repeat as well, but the ROM here is coming off of when all 3 of these are at 1, so that's the top of the addressing range. Then Y7 will go 0, which is the chip select for the ROM. If address 13 is low, so we've got 110, then Y6 will come on and that will address the RAM. These are ROM and RAM chips that will be on the actual board. So there'll be 3 chips on the board, and that's just the edge connector. So if we look at the actual board, we switch cameras. The actual board is this board here. RAM and ROM. The ROM's missing at the moment. That'll be plugged in there, and when that's plugged in, the idea is the KIM will boot off of this board and not this one here. Thus we can run our own diagnostics code on this to see what's happening about that D0 and D1. You see I'll put a link in here that jumps across that spare way, which jumps onto this wire link going across here, which is for the onboard decoder IC. Here's the actual ROM chip I should program. It's got something else on at the moment, so it needs erasing. And I found online this little device. It's meant to be a sterilising UV device. It plugs in a USB port. Just plug it in with a lead, and it's very good at erasing these. It takes 5 minutes, if that. I generally do it for about 10 minutes just to make sure, and then I'll reprogram that with a bit of code, and we go off and test some RAM and ROM. So here's the code we'll be putting into the ROM. Starts at the ROM address, the top ROM address. There could be 4 of these. That'd be E0, E8, F0 and F8. That's we'll pick the top one. A few knobs to start with. I want the vector to come in at a location rather than just starting there, so I just picked F8 22, pretty much like the actual monitor ROM, which comes in at 1C22, but we'll be jumping in at this point. First thing we do is load the X register with 0, and we store that out to D800, which is the first RAM address. That's the RAM on this board we're plugging in. Then it's going to load it back into the Y register, so it's going to read it back in. So that's write out to RAM, read back in from RAM, and then it'll write out again to a slightly different RAM address. So we can see the data bits going on and off and address bits changing. Then we increment the X register, and we loop back round to here, and we write it out again. So instead of writing out a 0, we'll be writing out a 1. And we'll keep doing that all the way through the numbers until it rolls over and just starts again from 0. So it's just round and round, so we can watch the data bus turning all its bits on and off, and the address bus moving a bit as well. And this bit here is just setting here's the actual reset vector here that we branch into. So this is to make sure we start at this memory location in the ROM. That's the very last bytes in this ROM. You have to tell it where you start from at the beginning when you're here, because it's got to calculate where this loop is to jump to. And if you don't tell it where to start, you'll be putting the wrong address in there. So I've erased the ROM. We read it. We find it's all FFF everywhere. Everything's been cleared. Now we need to program that. So it's loading the binary we want. This test one. Oh, wrong button. There we go. That's what we want to program into it. Just that small loop we just showed. So we program that in. All right. And it says it's programmed it. Let's read it back to make sure. And there we go. That looks like it's correct. So we can plug that into that board and we can run it. We get it around the right way. And a bit of a crunch. Right. What we need to do is unplug this connector. Oh, it's tight. Plug in our board. Now this new board has got its own power supply leads. This lead here. That's an 0 volts. That will set up for connecting to logic analyzer. Don't really need that. Thank God for the old power supply. Back in there. Put in there. Double check we're going the right way. Yep. And turn it on. And well, put in some current. See what the scope says. Right, that's scope plugged in. Let's see if we've got any signals. There we go. We got instructions running. You notice they're a lot evener than before because it's just a simple loop. I think we need to fire the logic analyzer at this and see what data we get from that. So if we bring up the disassembly listing of it, so we've got the actual hexadecimal codes. We've got starting at address there, which would be here, address 22. The disassembling hasn't got the full addressing on there because I only disassembled the first bit. So first instruction there is A2, which is load X with 0. Load X, and it will be bringing in the 0 there. Let me move this over a bit. We should have the phase 2. Ooh. That should load in on the phase 2 clock somewhere. Well, should be loading the 0 in. We've got a lot of bouncing going on here. Next instruction is 8E. There we go. That's the next instruction, which is coming from this 23, which is for the 0. Phase 2, loading the 0. This is just the bits changing state. And a new address in there of 24. So at 24, we've got 8E. There's 8E getting strobed in there. So that's the next instruction, which is store X into the next address. So if we move over and bring that back, where are we? Here. Zero D8. These are around the wrong, be swapped around. Well, this is interesting. We've got some funny things going on here. I don't seem to be following it. AE. from 1824. And then the addressing just goes all over the place. I should have a 00D8 coming in here. That is peculiar. I'm going to sample this again with the logic analyzer, redo it, and see if we get different numbers the second time around. And let's go for another one. See what we get this time. I've reconfigured the pulse view to give the full address as well. Alright, so I'm going to load that in. That one. And I need to, store the session setup. Looks the same to me. And we get rid of that one. And zoom in and see what we're getting. Alright, so, ooh, something's wrong with this address. Level there. So there's our F822. So why is it saying 7? Top bits on. This is very confusing. There's the A2 and the 0. The address down here is all, what we've got recorded here is mumbo jumbo. So we've got 22, and that's the reading FC and FD. I don't know why the top address is, oh, I know what it is. I know what it is. It's, only does 15 on here. You have to, oops, 16, yeah, to do 16. Believe it is 0, it doesn't do it properly. There we go. It's pulse view, another quirk on pulse view. Right, so start again. Here we go. A start vector loaded from there and there into the address. Here we go. F822. A2. Bring it up. A2. 00. And we've got 8E from 24. Now for some reason we go to this address. 01F8. Why are we losing all the address bus? Let's pull the ROM and make sure the ROM's programmed properly. Could it be it's not programmed right? Okay, I'll put the ROM into the reader. Let's read what it says. So we've got full C22 up there, blah blah blah. We're coming at 22, which is A2 00 8E. Oops. 8E 00 D8 AC 00 D8 8C 01 8D E8 4C 24 F8. That's the program. Okay, found out the issue. It was in single step mode. I put it into one mode. Well, I'm not sure. The switch is confusing. I don't know which is on and which is off. I'll switch the switch and I think it might be working. Let's start again, go through them all. I've just done a recapture. So here we go. There's the F822. It's over there. There's A2 loading in. That's store 0 in the X register, or load 0 into the X register. Then B8, which is store X in address 00. the D8, as we was expecting. Saves the data out. So that's the number 0 will be put out on the address bus somewhere. So here's the addresses counting correctly again. So F826. There's the 0 that's been stored into that RAM address. So that's on the RAM address and we put a 0 out. If we roll along, D8, then next one is AC 00 D8 00. So it's load the Y register from that address from D8. So we're reading, that's the address gone out. That's the next byte. So load Y from D0. Oh, sorry, there's the 0, the address, there's D8. The address bus has gone there, and then we're reading back in 00. So successfully put a 0 into the X register, stored it out, and loaded it back in. Let's see if we can. The next one is AC. Oh, we might have gone a little bit too far. Where are we? Oh, go back to the beginning. Start again. Okay, there we go. There's AC. AC. Load Y from that address. And there's the load in. Then we've got an 8C. So the next one. Let's see. Well, it's this one here. So let's store Y into that address. So store Y into address 0 D801. So there's D801. And we should have Y put onto the data bus. There it is, 00, because we had 0 in there, because it's the first one round. Then E8 is increment the X register. We won't see anything there. Then 4C is branch back to F824. So F8 and 24 is there. So we'll scroll along. Back to F824, which is here. It's E8 08. So storing that address, the X register, which is now 1. So 1's been put into there. And now AC is load the Y register from that address, and here's the one come back from memory. That memory address has come back into the Y register. So that's going round and round okay. 8 bit 0 is definitely turning on and off there. So we know the data bit bus is okay. It's something to do with that ROM chip, the one on the board. We's a bit further up here. Let's see if we get any bigger numbers we get. Only bit 6 coming on. Oh, what we got here? Oh, that's coming on from RAM, so we're definitely getting it come on. There's an F8. We've got the bit on there. So we know our bits are going on and off okay. That ROM chip's not working properly on the board, which is the bit we can't replace. Well, board is not lost because I think I might build an emulator for it. Unfortunately, it's only running at 1 MHz. And if I can put a much faster PIC chip on a board, I might be able to program it up to emulate the ROM and the I/O it's got on there, and the RAM and the timer. Can't actually drive any of the LEDs or keyboard at the moment because they're all done from that particular chip. Let's test the RAM. Well, I think I'll test the RAM in the next episode. I think we've done enough testing for this one. So don't forget to put lots of comments at the bottom and like and subscribe. And hopefully I'll be able to get this doing a bit more in the next episode.